I'm going to tell you two things today. One is what we have lost, and two, a way to bring it back. And let me start with this. This is my baseline. This is the Mediterranean coast with no fish, bare rock, and lots of sea urchins that like to eat the algae. Something like this is what I first saw when I jumped in the water for the first time in the Mediterranean coast of Spain. Now, if an alien came to Earth, let's call him Joe, what would Joe see? If Joe jumped in a coral reef, there are many things the alien could see. Very unlikely Joe would jump on a pristine coral reef, a virgin coral reef with lots of coral, sharks, crocodiles, manatees, groupers, turtles, etc. So probably what Joe would see would be in this part, on the greenish part of the picture. Here we have the extreme with dead corals, microbial soup, and jellyfish. And where the diver is, this is probably where most of the reefs of the world are now, with very few corals, algae overgrowing the corals, lots of bacteria, and where the large animals are gone. And this is what most marine scientists have seen too. This is their baseline. This is what they think is natural, because we started modern science with scuba diving long after we started degrading marine ecosystems. So I'm going to get us all on a time machine, and we're going to go to the left. We're going to go back to the past to see what the ocean was like. And let's start with this time machine, the Line Islands, where we have conducted a series of National Geographic expeditions. This is an archipelago belonging to Kiribati that spans across the equator, and it has several uninhabited, unfished, pristine islands, and a few inhabited islands. So let's start with the first one, Christmas Island, over 5,000 people. Most of the reefs are dead, most of the corals are dead, overgrown by algae. And most of the fishes are smaller than the pencils that we use to count them. We did 250 hours of diving here in 2005. We didn't see a single shark. This is the place that Captain Cook discovered in 1777, and he described huge abundance of sharks biting the rudders and the oars of their small boats while they were going ashore. Let's move the dial a little bit to the past. Fanning Island, 2,500 people. The corals are doing better here. Lots of small fish. This is what many divers would consider paradise. This is what you can see in most of the Florida Keys National Marine Sanctuary. And many people think this is really, really beautiful, if this is your baseline. If we go back to a place like Palmyra Atoll, where I was with Jeremy Jackson a few years ago, the corals are doing better, and there are sharks. You can see sharks in every single dive, and this is something that is very unusual in today's coral reefs. But then if we shift the dial 200, 500 years back, then we get to the places where the corals are absolutely healthy and gorgeous, forming spectacular structures, and where the predators are the most conspicuous thing, where you see between 25 and 50 sharks per dive. What have we learned from these places? Well, this is what we thought was natural. This is what we call the biomass pyramid. If we get all of the fishes of a coral reef together and weigh them, this is what we would expect. Most of the biomass is low in the food chain, the herbivores, the parrotfish, surgeonfishes that eat the algae. Then the plankton feeders, these little damselfish that eat the little animals floating in the water. And then we have a lower biomass of carnivores and a lower biomass of top predators, the sharks, the large snappers, the large groupers. But this is a consequence. This view of the world is a consequence of having studied degraded reefs. When we went to pristine reefs, we realized that the natural world was upside down. This pyramid was inverted. The top predators account for most of the biomass, in some places up to 85%, like Kingman Reef, which is now protected. The good news is that in addition to having more predators, there's more of everything. The size of these boxes is bigger. We have more sharks, more biomass of snappers, more biomass of herbivores too, like these parrotfish, that are like marine goats. They clean the reef. Everything that grows enough to be seen, they eat, and they keep the reef clean and allow the corals to replenish. Not only these places, these ancient pristine places have lots of fish, but they also have other important components of the ecosystem, like the giant clams, pavements of giant clams in the lagoons, up to 20, 25 per square meter. These have disappeared from every inhabited reef in the world, and they filter the water. They keep the water clean from microbes and pathogens. But still, now we have global warming. If we don't have fishing, because these reefs are protected by law or by their remoteness, this is great, but the water gets warmer for too long and the corals die. So how are these fish, these predators, going to help? Well, what we have seen is that in this particular area, during El Nino year, 97, 98, the water was too warm for too long, and many corals bleached, and many died. In Christmas, where the food web is really trimmed down, where the large animals are gone, the corals have not recovered. In Fanning Island, the corals are not recovered, but you see here a big table coral that died and collapsed, and the fish have grazed the algae, so the turf of algae is a little lower. Then you go to Palmyra Atoll, that has more biomass of herbivores, and the dead corals are clean, and the corals are coming back. And when you go to the pristine site, did this ever bleached? These places bleach too, but they recover faster. The more intact, the more complete, the more complex is your food web, the higher the resilience, the more likely that the system is going to recover from the short-term impacts of warming events. And that's good news. So we need to recover that structure. We need to make sure that all of the pieces of the ecosystem are there, so the ecosystem can adapt to the effects of global warming. So if we have to reset the baseline, if we have to push the ecosystem back to the left, how can we do it? Well, there are several ways. One very clear way is the marine protected areas, especially no-take reserves that we set aside to allow for the recovery of marine life. And let me go back to that image of the Mediterranean. This was my baseline. This is what I saw when I was a kid. And at the same time, I was watching Jacques Cousteau's shows on TV with all this richness and abundance and diversity. And I thought that this richness belonged to tropical seas and that the Mediterranean was a naturally poor sea. But little I know until I jumped for the first time in a marine reserve. And this is what I saw. Lots of fish. After a few years, between 5 and 7 years, the fishes come back, they eat the urchins, and then the algae grow again. So you have this little algal forest, and in the size of a laptop, you can find more than 100 species of algae, mostly microscopic, feed hundreds of species of little animals that then feed the fish. So the system recovers. And this particular place, the Medas Islands Marine Reserve, is only 94 hectares, and it brings 6 million euros to the local economy, 20 times more than fishing. And it represents 88% of all the tourist revenue. So these places not only help the ecosystem, but also help the people who can benefit from the ecosystem. So let me just give you a summary of what no-take reserves do, these places. When we protect them, if we compare them to unprotected areas nearby, this is what happens. The number of species increases 21%. So if you have 1,000 species, you would expect 200 more in a marine reserve. This is very substantial. The size of organisms increases a third. So your fish are now this big. The abundance, how many fish per square meter you have, increases almost 170%. And the biomass, this is the most spectacular change, 4.5 times greater biomass on average, just after 5-7 years. In some places, up to 10 times larger biomass inside the reserves.